Hello, 8th grade math students. Mr. Lawrence here, and today we are going to be solving systems of linear equations by graphing. Yeah, we talked yesterday about how to find out how many systems or solutions there were to the system. Today we're going to solve by graphing. Now, you see I've got some things prepared here. I'm just going to get them out of my way. Okay. First off, I want to make sure that my equation is in slope-intercept form. So right now, y is not alone. So I'm going to subtract x from both sides. And when I do that, be careful here. This is a really common mistake. I'm going to get a negative y equals negative x minus 1. Now, y is not alone. There's a negative 1 attached to it, right? By multiplication, because there's a negative y there, or negative 1y. So I'm going to divide by negative 1 in all three, or on all three terms. And when I do that, I'm going to get y equals x plus 1. All right, so now I'm ready to go ahead and graph. I can get the y-intercept of 1. And my slope is also 1, or 1 over 1. So I'm going to rise 1, run 1, rise 1, run 1. And I'm just going to put a whole bunch of points on here. And you'll see why in a minute. Okay? Just dragging a whole bunch of points using my slope. And I think this line is already ready to go. Bam, just like that, going right through all those points. Okay, with the blue equation, I have to do the same thing. I have to make sure we're in slope-intercept form, which means I have to get y alone. So I'm going to subtract 7 from both sides. Okay, and so I'm going to get y equals 3x minus 7. So now I know my y-intercept is negative 7. So let's see, 2, 3, 4, 5, 6, 7 should be right there. And my slope is 3, or as a fraction, 3 over 1. So I'm going to rise 1, 2, 3, and run 1. Okay, I'm going to rise 3, 1, 2, 3, and run 1. Right? I'm going to rise 3, 1, 2, 3, and run 1. Can you see it yet? I'm going to rise 1, 2, 3, and run 1. Look at that. Those 2 points are in the same place. 1, 2, 3, and run 1. That's the solution right there. That's where the 2 lines are going to intersect. Yeah. Let me extend that line a little bit, make it a little bit more accurate there. There we go. And now you can clearly see that they are intersecting, there we go, at this point right here. What are the coordinates of that point? Well, let's see. The x-coordinate is 1, 2, 3, 4. And the y-coordinate is 1, 2, 3, 4, 5. The solution to the system of x minus y equals negative 1 and y plus 7 equals 3x is the point 4, 5. What that means is if I put 4 in for x and 5 in for y, 4 minus 5, I get negative 1, don't I? It's a true statement. If I come over here and I put 5 in for y, 5 plus 7, right, is 12. And over here, I'm going to have 3 times x's value, which is 4, and 3 times 4 is 12. You see, I get a true statement. That point is on both lines. Now you can check this really easily using Desmos. Such a cool thing to be able to do. So I want you to pause the video. I've given you 2 equations here. You go ahead and solve them. And then you can watch my solution, all right? Okay, here comes my solution. If you haven't tried it yet, go right ahead and do it. Pause the video and try it. Here we have slope-intercept form, y equals 2x plus nothing, right? Plus 0. So my y-intercept is the origin. It's at y equals 0. Okay, my slope is 2, or 2 over 1, so I'm going to rise 2 and run 1. And I'm going to rise 2 and run 1. And I'm going to rise 2 and run 1. And I can rise 2 and run 1. All right, so I can draw my line now. So I'll put that on the origin. And I'll put that through there. And notice I make my line take up the whole graph. I take up a lot of room there. That line goes forever. I want it to look like it does. The blue one, y-intercept is 4, so 3, 4 right there. And then my x-intercept, oh, excuse me, not my x-intercept, my slope is -6, or -6/1. So I'm going to go down 1, 2, 3, 4, 5, 6, and then over 1. Uh-oh, I'm going to sneeze. Sorry about that. All right. Oh, they travel in pairs. All right, sorry about that, guys. Okay. So let me get one more point on there. So I'm going to go down 6, 1, 2, 3, 4, 5, 6, and then over 1. Uh-oh, I don't like this one as much. Look at what's going to happen here. Okay, I'm going to put that right there. I'm going to bring that down to here. Look at that. You can't really tell exactly where the two lines are intersecting. I mean, it sure kind of looks like they're intersecting right here at this point, but it's really difficult to tell. We can only guesstimate it. The y-coordinate sure looks like it's 1. Okay. The x-coordinate, geez, it looks like it might be 3/4, but how do I know it's not 4/5 or 76/100 or something like that? I can't tell. That's the problem with solving by graphing. If they don't land at a perfect intersection, it's difficult to know the actual solution. So you have to do a little bit of guessing. There are other methods you're going to learn in Algebra 1. I don't know if I'm going to show them to you in this class. I think I'll wait for your Algebra 1 teacher to show you. But you will be doing some of these on the homework where you have to kind of guess as to where they're at. You can make an educated guess, but it's hard to be exact. All right, let's take a look at a story problem here. It says, photographer Penelope charges $25 for her starter package and 50 cents for each additional pick. Oh, wow, I got an equation right there, right? Did you hear that equation? Let's see here. So I got Penelope. I'm going to do Penelope in red. Okay, Penelope will be in red. And it's going to be y equals 50 cents x plus 25, right? Okay. And then Pete, I'll do Pete in blue. Pete has the same starter package but charges $30 for it and 37.5 cents for each additional pick. So Pete's equation would look like this. 0.375x plus 30. Now the problem is, if you take a look at the graph, it's going to be really hard to graph 375 1/1000ths rise and run. So I'm going to manipulate these equations. Okay, I'm not going to mess with the y-intercepts. The y-intercepts are cool. I'm going to put Pete's y-intercept at 30 and Penelope's y-intercept at 25. That part is no problem. But taking a look at this graph, it looks like they're counting by 4s along the x-axis. Well, let me see what I can do to manipulate this. All right. I'm going to take the slopes. Let me start with Penelope's slope, which is 50 cents per picture. All right. Now, I know they're counting by 4 on the x-axis, so I'm going to multiply both the numerator and denominator by 4, and I will get 2 over 4 because $2, 50 cents, 50 cents, 50 cents, 50 cents makes $2, right? 50 cents times 4 is $2. The only problem with that is they're not counting by 2s along the y-axis. They're counting by 2 50s, but it'd be easy to tell if they were counting, like to count by 10s. So I'm going to multiply by 5 here and here. And I'm going to make the slope look like 10 over 20. And so for Penelope, I'm going to rise $10 for every 20 pictures she buys. All right, or that you buy from her. Wait, Penelope's in red. Yeah, okay. So I'm going to rise $10, and that's going to be for 20 extra pictures outside the starter package. And then I'm going to raise $10 and go 20 more, which is going to be there. Hey, James, not so much noise. Sorry about that. My son is playing on a chair in the background. All right, so I am going to raise $10 and go $20 more. Okay, now I don't know if you realize this, I could cheat. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. So to put this last point on here that I want to put, I'm going to raise 1, 2, and I'm going to go 1, 2, 3, 4, 5. Now, this really shouldn't be continuous data. I should not draw a line here. There should be more points on the line, but if you think about it, it should be discrete data because you can't buy like 3.5 pictures. You can only buy pictures in whole number amounts, right? So I'm going to go ahead and do it just because we're trying to solve the system and we want to find out where these intersect. But technically speaking, I shouldn't really have them be a solid line in that way. Okay. Now I'm going to do something similar with Pete's slope. I've got this 375 1,000ths over 1, right? Which doesn't really make sense. I'm trying to make it make sense. The first thing I'm going to do is multiply the numerator and denominator by 10. And when I do that, I'm going to get $3.75. Yeah, that's right. Felt like I made a mistake. Over 10. That doesn't really help me. But if I think about 375, oops, that's not 375, hold on. 375 and 375, well, that makes 750. Okay, so that would be 750 over 20. Well, I just multiplied them both by 2. And then if I multiply both of those by 2, I will get $15 for 40 pictures. So that's the slope I want to use. Okay, so I'm going to rise $15. So 5, 10, 15, but then go over to 40. Oh, look at that. Look at that. It's hitting that point right there. Let's rise 15 and then go over to 80. And there we go. If you want to check that, it's rise 1, 2, 3, and then run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Rise 1, 2, 3, and then run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm feeling pretty good about that. Let me do it this way. It might be easier. I'm just going to clone this line. Maybe. There's kind of a lag going on. And I'm going to make it blue. All right. And I'll put this end at the y-intercept. And I will put this end there. And sure enough, they're intersecting right there. So the question had asked, when is it better to go with each photographer? And is there ever a time that it would cost the same? Well, let me erase all this and get it out of my way. And I would say, I would answer the question something like this. Extra point out of my way. Okay. The photographers charge the same. Same amount for 40 extra pictures, right? That would be the point. 40 and $45, right? For 40 extra pics. If you order less than 40, the red one is cheaper, which is Penelope. Penelope is cheaper. If you order more than 40, Pete Sorry, got a little lag going on there. Pete is cheaper. And there you go. All right, so that's it for the video. We were solving systems by graphing. That's what we were doing. All right, that's it. Mr. Lawrence signing off. Have a good night, everybody.